Okay, and we are live. Hello to everyone watching this. I'm Nolan Hartwick, and this is the review session for November 27th of the UCSD Data Science and Visualizations course. Today we will be going over some built-in Python functions, some of which you should be aware of, and others you may not currently be aware of, as well as basic usage of a library called PyMySQL, which is basically going to let you execute SQL queries from within a Python environment. Unless there are any questions before we begin, I'm going to dive right into it. Any questions?
Nope.
Sounds good. All right, so you should see before you a Jupyter notebook. And we're just going to quickly go through some functions that are just always available to you whenever you're working in Python. The first function we're going to be looking at is the type function, which is going to let you print the type of an object. Every object in Python has a type. So when I execute this block of code, you'll see that we created a list of items. The first item in that list is itself an empty list. The second item is a string. Third item is an integer. The fourth item is 5.0, which is a float. And the fifth item is an empty dictionary. And then for each of those items, we're going to head and call type on that item and print a nice formatted string so that we can see it. We can see that the empty list is in fact a list. This string is a string. 5 is an int. 5.0 is a float. And these curly braces, which represents an empty dictionary, is a dictionary. This is somewhat, you're going to use this whenever you're working with code that you're not very familiar with, and you just want to see quickly what the return types of a function are. This is particularly important when you're working with less well-documented libraries, which happens from time to time. It's more of a diagnostic tool than anything. Any questions on the type function? Okay, moving on. So another function that you guys have definitely seen but probably aren't using is the help function. The help function is going to let you see an object's docstring, and the docstring is basically the string on an object, which is the documentation for the object. So here I create a list object and I call help on that list, and it's going to give me the documentation for the Python list. Next, I'm going to just do a quick print line to add some space, and I'm going to talk about that function in a bit. But first, this is what the help on the list object looks like. You will see that we're working with the class list. It isn't iterable. Even if you guys don't quite know what that means, basically it means that you can iterate over it. So like for x in list. And you can see that it has all these various functions that are accessible. So you can call mylist.copy, mylist.clear, mylist.count, and give it some value. Basically, all of the documentation that is available online is available and built into the Python implementation itself. So next, this is something you guys should start doing whenever you define functions. You can actually create your own docstrings. So here I've defined a function called fib, and it's going to go ahead and it implements the Fibonacci sequence. So it's going to tell you what the nth term of the Fibonacci sequence is. And it does it recursively, but that's not that important. And what I've done here is the first string after a function definition becomes that function's docstring. So this entire block of text is the docstring for fib. And you can see that I give some basic description of what it does, define the parameters, and give some example of its usage. And when you go down here, you can see that we called help of fib. and it went ahead and printed that doc string. You guys should be doing this on your Python functions. It makes it a lot easier to go back and look at your code in the future. And documentation is good. It's kind of a pain in the ass, but it's good. You don't have to use this format exactly. You can use whatever format you like, but try to keep it reasonable. Any questions on the help function or doc strings?
Yeah, Nolan, when the doc, oh, I see, never mind. Now that you went above, I see where you established the doc string, quotes.
Yeah, it's just the first string that occurs after the function definition.
Right.
So yeah, that's a helpful function whenever you want to get the documentation for any object in general. You can also just go online. It's always available online, at least usually, not always, but. The next group of functions that I want to get into, these are the built-in math functions. These are pretty straightforward and do what you expect them to do. The ABS function is the absolute value function, and it's going to give you the absolute value of some number that you pass in. So x is -3. The absolute value of -3 is ABS of x. Quickly run this. The absolute value of -3 is 3. Yeah, I assume everyone is familiar with the concept of absolute values. The divmod function is kind of a weird one, but basically it's going to let you do integer division and let you get both the result and the remainder in a single calculation. So I can say, what is 7 divided by 2? It's going to be, this is the result, this is the remainder, and divmod of value divisor. So 7 divided by 2. And there's this nice helpful doc string that demonstrates what this does. 7 divided by 2 is equal to 3 remainder 1. Any questions on either of these quick functions?
What library do we need to call in order to make use of these functions?
None. These are built in. These are always available to you.
Got it. Thanks.
Any other quick questions? Okay, moving on. You guys have been introduced to all of these, but I thought it would be worth quickly reviewing them. There are 4 default collection objects that are available to you at all times. The first, and the one you're most familiar with, is the list object. And you can create lists using the list function or by using the bracket notation. You can create tuples, which are, going back a sec. The important thing about a list is that it's a mutable ordered collection of objects. You can change it, you can change a list after you make it, and the elements have a sequence to them. There's a sense in which one item is at position 0, a different item is at position 1, and so on and so forth. Tuples, which can be created using the tuple function or with the parentheses, are immutable ordered collections of objects. They're just like a list, except you cannot change the values in a tuple. If you have my tuple, you cannot say my tuple 0 equals 5. Like, just really quickly. This will not work because tuples are not mutable. You cannot change them. The next collection that you should be familiar with is the set. A set is an unordered and unique collection of objects. So you can see that and you create a set using the set function. You can see that I'm passing in a list of 4 items, but Nolan occurs twice. And as a result, when I run this, you can see that when it's in the set, each item only appears once instead of Nolan being in there twice. This is really handy when you want to find out the unique items in a list, let's say.
Huh.
Hmm.
That's interesting, actually.
What if Nolan is in small letters
If it's
and one is big and one is small?
this string, sorry, the lowercase Nolan and the uppercase Nolan are different strings. So when I run this, they will both appear. Also worth pointing out here is that sets are not ordered. I pass it in Nolan, Nolan, Bob, Jane. I got out Nolan, Jane, Nolan, Bob. There is no sense in which any of these elements have a special position in this set. Items are either in a set or not in a set. They are never found at a specific position in a set. Does that make sense?
Yes.
Yeah. So the final object that you should be familiar with is a dictionary. And dictionaries can be created using either curly braces or the dict function, which if you use the dict function, then it expects a list of tuples. The tuples represent key value pairs. And dicts are unordered mappings from unique keys to objects. So when I run this, it's going to create a dictionary that maps Nolan to me, Bob to not me, and Jane to not me. You can see that my dict contains Nolan and it maps to me, Bob maps to not me, and Jane maps to not me. Any questions on any of these collection objects, collection types?
No, but that last one was especially helpful. I forgot that you set it up differently when the dict function is called.
Yeah, the dict function expects different.
Mm-hmm.
Yeah. All right. The next couple of functions that I want to talk about are meant to be. You can call them on any of these iterable collections. You can pass a list to them, or a set, or a dictionary, whatever you want. And the first function I want to talk about is the all function, which is going to tell you if all of the elements of some collection are true. If they are not all true, it's going to return false. So just real quickly, I defined 3 different collections here. The first one, all of them are true, 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 true. The second one is false, true, false, true. And the third one is all are false, 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 false. And these are just some quick print statements that show you how it works. All of true, true, true is in fact true because all of the items are true. All of true, false, true is false. All of false, false, false is still false. But we can actually do more stuff with this using list comprehensions. So let's say I have a list of numbers and I want to know if all of my numbers are less than 5. Well, it's really easy to do that using comprehension syntax. So you can say all of x less than test file for x in my nums. And this is basically asking, so this is basically creating it's kind of like a list of true false values comparing 5 to each of these numbers. And then you call the all function on that collection. And you can see that 4, 5, 6, 8, 2 are all less than 5. They are not. That statement is false. But if I were to change this to, let's say, 10, now it will be true. Similarly, or any questions on the all function? Okay, then. The next function that I want to talk about is the any function, which is basically, it's kind of like all, except instead of doing and logic on all of the elements, it's doing or logic. It's going to return true if any of the elements are true. So true, true, true returns true. any of true, false, true returns true because at least one element was true. And any of false, false, false was in fact false. And we can also do the same type of thing we did before using a comprehension. So any of the same numbers we had earlier. So in this case, we're comparing 4 to 10, and then 5 to 10, and 6 to 10, and 8 to 10, and 2 to 10. And then we were asking if this, oh, sorry. Undo. That didn't work. So in this case, we're asking if this expression is true for any x in our numbers. So is any number less than 10? And because all numbers are less than 10, it's in fact true. Any questions on the all function or the any function?
Not really. I mean, obviously, one of those numbers is false, right? And it's like the Boolean.
Yeah, no, they work how you expect them to.
Okay.
It's just handy to have.
Okay.
These are other functions that you guys should already be familiar with. The max is going to find the maximum value in some iterable. The minimum function finds the minimum value. The sum adds them all up. So the max of this list is 9. The minimum is -2. The sum is 14. Pretty straightforward. You guys are used to these, right?
Yeah.
All right. This is one you guys may not have seen. There are actually two functions. So the zip function is really handy when you want to iterate over 2 lists at the same time. So in this case, it's going to, instead of iterating over this first list or the second list, I can iterate over them together by zipping them up using the zip function. And you just go zip of iterable 1, iterable 2. And instead of iterating over either of the lists, you iterate over both of them, and you get a tuple. So you could do something like for val1, val2, and zip iterable 1, comma, iterable 2. Yeah. Things to note, zip is going to halt. Zip will return however many items is found in the smallest of your collection. So if you have different length lists, if this iterable 2 had 4 elements, let's say, then zip would only get you the first 3 elements in the second list. But it is quite handy when you want to iterate over 2 items at the same time. The next function worth talking about is the enumerate function, which lets you iterate over both the index of an item and the items themselves. So when I call enumerate of 025, instead of getting 025, I get 00. Tells me at index 0, we have item 0. At index 1, we have item 2. At index 2, we have item 5. And you can do all sorts of cool list comprehensions with this. This is just a toy example. But if you were ever doing And you ever see this line of code? If you ever write this line of code, you're doing it wrong. You should not do this. You should just write underscore or whatever you want, some throwaway. Those were equivalent statements. Just a handy thing to have, handy tool to have in your pocket whenever you're iterating, whenever you need the index of items. These next ones are pretty straightforward. Sorted function is going to sort some iterable. The reverse function is going to reverse the order of some ordered iterable. So 2404 turns into 0244. 2404 turns into 4042 when we reverse it. Now, the next thing we're showing you guys is a function that you have seen before, but probably aren't familiar with or understand particularly well. So Python has these things called iterators, which let you step through collections and touch one element at a time, basically. The next function is going to let you take a step with some iterator. So I first start by creating an iterator. And to do that, I just call enumerate on iterable 2, which was this list up here. And enumerate is going to let me iterate over the index and the items. So when I call next on my iter, I get the 0 index and the item found at the 0th index, which is 2. When I call next again on that same iterator, it gives me the second item in the list at index 1, which is item 4. When I call next again, it gives me the third item, which is at index 2 and is item 0. If you keep calling next, you're going to get an exception. Oops, my mistake. I actually modified iterable 2, so now it has 4 items. But we can run this again. Once an iterator is exhausted, calling next on it is going to return this exception. Something to be familiar with. If you ever see this exception, it's because some iterator, some iterable, something is iterating over something and didn't have as many items as it expected. Any questions on any of these built-in functions? Okay then, moving on. So PyMySQL is a Python module which makes it really easy to execute SQL statements and connect to databases and read data from databases. You can install it using pip install PyMySQL. You can read the documentation at this link. And let's just quickly run that. So here I'm importing pandas, I'm importing PyMySQL, and I'm also importing my password from a config file because you guys don't get to see my password. When you're using PyMySQL, you start by making a connection to some database. This is very similar to when you're using SQL Workbench. You start by connecting to some server. And in this case, I'm connecting to my local server, which I set up earlier today. And I'm logging in as root. I'm using the password that I imported. And this cursor class thing is optional. I'd recommend using the dict cursor. It makes it so that when you get items from the SQL database, you will get them as, you will get rows as dictionary items instead of just tuples of items. Basically, it lets you easily infer column names. So I'm just going to quickly connect to the database. When you're working in PyMySQL, the thing that you use to read the database and execute SQL statements is called a cursor object. And to create a cursor object for this connection, I call connection.cursor and define that to be equal to cursor. I can then execute basically any SQL statement I want. In this case, I have the Sakilla database, which is something that you all should have if you installed MySQL correctly. It has a variety of tables in it, including this table, which is actor, with all sorts of data in it. And I'm just going to go ahead and get all of the data from it. This is going to execute some statement, and basically the data is going to be, it's not quite going to get you all of the data. In order to actually get the data, you need to call cursor.fetchAll. And in this case, I'm passing it to a data frame just because it's easier to see. So you can see that this information matches up perfectly with this information. Penelope, Guinness, some date, and Penelope, Guinness, some date. I have executed a SQL statement inside of Python. You do not need SQL Workbench, although I do recommend it for a variety of things. So what if we want to do something else? What if we're working on some project and we need to set up a database and we want to write a script to do it? So we have some table that we want to create, and we can execute a typical SQL query to create the table. In this case, I'm going to create it in the Sakilla database, and it's going to have a primary key ID, which is going to auto increment, and we're going to have some name, which is a 30-character string. Now, whenever you make a change to a database and you're using PyMySQL, the last thing you need to do is call connection.commit, which is going to make sure all of your changes that you want to make actually happen. If you don't call connection.commit, then the changes you're trying to make won't happen. But you can see that I can run that. And if I go back to my database and refresh my table, you can see that I now have a new database, my new table. And it's got nothing in it because I haven't put anything in it. And that's fine, because that's what my next block of code does. So I'm using the results from before, but you could use any data you want. And you could basically, you can execute a whole bunch of SQL queries, or in this case, SQL commands, really quickly and easily using standard Python logic. So for each of the names in this column of data, I'm going to insert that name into my new table. And then I'm going to commit the changes so that they actually take place. And when I go back and I go my new table, click there, you can see that now this database is populated with all sorts of cool data. Hooray! 3 lines of code, and I input 200 entries or whatever, however many entries it is. And this next command is just a quick selection to demonstrate that that data is actually inserted. And it can show you that. These final 2 commands are just me cleaning up. This is how you end a connection to a SQL server. You call connection.close. And this is how you drop a table. And this is what I was doing because I don't want this new table in my database. So whatever. I don't need it. I dropped it. It's gone. And now you can see that that table is no longer here. Sad days, no more data. So yeah, that was just a really quick, brief overview of what you can do with PyMySQL. In general, you can execute arbitrary SQL statements and connect to any database that you have access to. This is one of many ways you can connect to SQL servers from inside of Python. If you want to read more about it, you can go read up on the documentation. We'll be using a different method of connecting when we start going over Flask, which is a web development framework, and that'll happen in like 2 weeks or something.
Okay.
But this is handy if you're ever trying to do quick and dirty setup of stuff, and you have a bunch of data that isn't currently formatted in a way that makes it easy to do things. Or if you're just writing custom scripts that need to interact with a database and do some analysis on the data without making a bunch of messy intermediary files.
It's really cool. Thank you.
So this last 20 or 30 minutes is Q&A, like always. If anyone has any questions on what I've shown you or questions in general, now's the time to ask.
I'm hoping to be able to review this stuff later. I suppose the Jupyter file somewhere we can access?
It is already uploaded to Slack.
Oh, you're the best. Thank you.
Note that in order to run this PyMySQL stuff, you need to make sure your database is up and running, and you need to make sure your password is entered here.
Okay. Yeah, it's not loading properly on the Mac, so hopefully I'll get some help on that tomorrow.
All right, well, come into class early, I guess. Yeah. Any other questions? Now's the time. See a lot of muted mics.
Now we're good. So, it was very helpful.
Cool. Yeah. Final stress. Use functions. Functions are great. Writing functions lets you make reusable pieces of code. And when you write functions, use docstrings. Docstrings are great for keeping track of what your code does.
Hey, Nolan, thank you so much for hosting this review session.
Yeah.
Where did you Slack the file, the Jupyter file? I couldn't find it.
Go to class announcements.
Yeah,
It
class announce.
looks like
It says
like
link to.
yeah.
Download.
Oh, you just have to download the snippet.
It's
Oh, okay, got it. I did
Slack
not see
thinks
the
the
one.
Python notebook files are plain text files. Slack is wrong.
Cool.
I don't know how to. I've not spent a lot to make it look better. But yeah, you can download by clicking this button.
I done did it.
It didn't do it?
No, I'm joking. I said I done did it. I did it. It works.
Perfect.
She done did it.
I done did it. That's right. I didn't use the accent.
Yeah, this is other things that might be worth pointing out here. So whenever you have parentheses that are doing some function call, if you have a list inside, if you have a bunch of strings inside of it, Python is just going to automatically concatenate these strings. So this is something that we've shown you before, but hasn't really been explicit. So I can just do my little pony. all three of these strings are just going to get stitched together because they're inside of parentheses.
Hmm.
This is a pretty handy thing to have access to whenever you're writing long and complicated strings. When you're doing SQL queries, that's one example of when they can be helpful. But you can see that I just decomposed this one big long SQL query into 3 different strings, just to make it easier for me to look at and read. It's also worth familiarizing yourself with the Sakilla database just a little. Your first homework is going to be using this database, or rather your next homework. All right, well, any remaining questions?
No, thanks again, man.
Not a
Thank
problem.
you. This is going to be really helpful.
Have you recorded this session, Nolan?
Should be, in theory.
I see in theory. Okay. Thank you so much, Nolan. Okay, and thanks everyone for asking questions.
Yeah, well, see you all tomorrow.
All right.
Come
Again.
help with-
See you tomorrow.
And I hope you all had a great Thanksgiving.
Yes, you too.
On that note, I'm going to go ahead and stop this broadcast.